We have two titration problems here. The only difference between a titration and any other stoichiometry problem is that you know at least once you're going to be using the molarity equation or a definition of molarity because we are definitely using a burette to precisely measure a volume. The other thing is because this is a technique often used to analyze, significant figures are as important here as they are anywhere. So when we read our problem, if we aren't given a balanced equation, we either need to write that balanced equation or look at the chemicals themselves to see how they would react. HCl and NaOH are an acid and a base. Hopefully, we would recognize that one H reacts with one OH to make water, and Na and Cl also combine in a 1-to-1 ratio. That allows us to recognize this 1-to-1 ratio, whether we write the balanced equation or not. We then start with the solution that we have the most information about. Volume and molarity of NaOH allows me to go from liters to moles using the fact that 0.1 moles per liters is the molarity. Whether you show this as a mole ratio or state it, you have to somewhere acknowledge that this calculation gets you the moles of NaOH, and we know that that's equal to the moles of HCl. It could be shown here or explained or stated elsewhere. The moles over the liters then gets us our final molarity, and we should see that that answer makes sense. And because the volumes are in similar ballparks, the molarities being somewhat close to one another makes sense. 4 digits, and 3 digits make sense with 3 in our final answer. In our second scenario here, rather than being a molarity to molarity, it gives us different information, but still a volume and molarity of a solution. It gives us an unknown monoprotic acid. Although we don't know what it is, mono means that there's one hydrogen on it, so it's still a 1-to-1 mole ratio. The volume times the molarity times that 1-to-1 ratio gets me the moles of, this should just be acid. And then this is a little bit different. We need to think about what do we have and what do we know, so how do we solve this problem? We know the grams, we know the moles, and grams per mole allows us to get to our molar mass. So we can analyze in a different way here, still finding out more information about our unknown.